Hi everyone. In this video, Mark will explain the various components of de-isotoping spectra in PPL. This is a major component of processing high-resolution mass spectral data. He'll give some insight into what each of the de-isotoping parameters do and how changing them might change your data output. He'll also go over how to edit a de-isotoping method file that you've already made. Reference our ProMass HR Quick Start Guide to see more information about using the software.
At this point now, we're ready to do de-isotoping, so I just say OK. And then this is kind of one of the critical things. This dialog allows you to customize what your isotopic template molecular formula is going to be. So if you're working with DNA, that's what we have in this box right now. So this would work for DNA or RNA. It'd be close enough for RNA as well, but if you had molecules that had sulfur in there, you would need to enter how many sulfurs you have. So if you have phosphorothioate oligos, for example, in many cases, those are every phosphate you have a sulfur. So for example, in this case, if I have a 20 base oligo, I would also have 19 sulfurs. You would need to enter that there. In this case, the data we have is straight DNA, so I don't want to enter any sulfurs. So if I'm running like generic oligos, you could leave this pretty much constant, because even if the overall molecular formula is changing, the actual ratio of the elements doesn't change that much. As long as the ratio of elements is fairly constant, it can track very nicely over a pretty wide molecular weight range. So if you have additional elements, you would select that with this feature here under Edit. Unfortunately, the software makes you add the elemental compositions, but this is pretty straightforward. You have to go and find out what the isotope intensities are. You can get that from Excalibur, but for most folks working with organic molecules that are either oligos or peptides or proteins, this dialog will give them what they need. Now, some of the other parts of this screen, one of the things about the PPL de-isotoping is it needs to know the charge range that it's going to be dealing with. Unlike ProMass, you tell it a mass range and then it figures out what the charges can be based on your input and output range. This thing has to know what the charges could possibly be. So it's kind of an unfortunate feature of the software. You have to keep that in mind when you're working with it. If you're not seeing the expected result and you're working with something at 20 bases and then you go up to 60 bases and you go, wow, why is this not working? It could be that your charge range is not set correctly. So usually when I save these methods, I will save them with a name that kind of tells me what my charge range was. Some of the other things here, you have to tick this box if it's negative ion data. And then there's also, like, when it does the de-isotoping, it uses different information based on what you select here. Like, how does it determine the de-isotoped mass? Does it use the first peak, or does it use the first two peaks, or does it use all peaks? And my general rule of thumb is if you have a reasonably intense C12 peak, which would be the lightest peak in your range, then I will use first peak only. As you get longer and longer oligos, I would use one of these two options because it could be that your C12 peak is really, really small. So on longer oligos, you may want to even use the all peaks function. I think for this oligo, let me just cancel out this and I can show you. If you zoom in, you can see this is our C12 peak. So it's pretty abundant. So you could use probably any three of the options and it would probably give you about the same result. I can just show you that. If we use the first peak, for example, on this data, we have 7399.282. Let's go back and try one of the other options. All peaks. 7399.264. So it's having an effect on that determined mass slightly. 7399.272 is the correct answer. Let's try the first two. 7399.280. So actually this is the closest one, right? If I'm looking at something like this, I would probably tend to use the first two. One of the things you can do is when you perform de-isotoping, you can actually look at the result and see how well you've done. Like ideally, I should have a single stick. And you can see in this case, I have a very clean de-isotope spectrum. There's no satellite peaks here. There's not an M-1 or M+1. When you don't have a perfect result, then you'll get some de-isotoping artifacts. So, for example, if I go in here and actually tell it I have sulfur, watch what happens. See, now the software has actually reconstructed another peak there because it thinks I told it it had sulfur. The other way is if I have sulfur and I haven't told it, then I will generally end up with some data over here on the side of the peak. So that's kind of a way you can check whether your method is set up correctly, is when you're working with your data, are you actually reconstructing a clean signal or are you getting these bonus peaks? You have to click around a lot more to get what you want. You see this little number sign? It actually will label the peaks. This is 6 charges, 7 charges, 8 charges, 9 charges, and so on. And then you can also look and see, like the overlay is showing what the ideal isotopic pattern would look like versus your PPL dick-ized, I don't know what you would call that, centroided. Yeah, so you can see the black, that's our, the black trace is our deconvolved peak list, whereas the orange is our overlay. So it's interesting, if you look, it looks like the higher charge state in this case doesn't fit as well as the other ones. I'm not sure why that is. That's almost like a perfect fit there. You can't even see the difference between the black and the orange. But anyway, once you have this the way you like it, then what you do is you can save this method. So what you do is you come up here and you say export method, and I'll just call it blah, and I'll call it Z1 through 25. That's what I like to do. Now once you have that method, you can use it over and over again. One of the things that's not covered in the user guide, which I should be adding, is once you've made your de-isotoping method and you have your method file, if you ever want to go back and edit that file, it's not trivial. So unless you remember to do this one step, if you go back to the main PPL program and you save the peak table, basically what saving the peak table does is it saves what you did through the last step of your method, like all the way through to where you get the sticks instead of the peaks. If you save that, if I close this now and then I decide later, oh, I really need to change the molecular formula a little bit to work with the S oligos versus non-S oligos. If I didn't save that, I would have to go through the whole process of modeling the peaks and everything. If I save a peak table, what I can do is I can go back into review and then just open the peak table file. Don't know where I saved it. There it is. Test 24 standard peak table. And you can see I have my deconvolved peak list just like I had generated at the end of my process before I de-isotoped it. So if you open that up and then you just go back into the de-isotoping menu, I can then change any of these parameters and then create a new method. Let's say I'm not really working with charge states up to 25. I'm just going to make them up to 15. Or maybe I do want to just use the first C12 method. I can take this and now save this as a new method. I could call it like blah 2. Now I can reuse that method. So if I save the peak table, I can easily edit my de-isotoping parameters and then go back in and save a new method. The only time you need to save the peak table is when you're done with all your modeling and stuff. The other thing that's helpful to know is how do I find out what my parameters were during the PPL steps? And you can always get that by looking at the log file. So even if you forget what you had done, if you go into your log file in your ProMass report, it will tell you all of your PPL processing parameters. It tells you, okay, here you baseline corrected the data, you used a left width of 2.09, a right width of 1.92, a left shape of 2.37, and a right shape of 2.17. You use a standard deviation of 2 and a 95% confidence to reject noise. And then here were your de-isotoping parameters. So this is very useful if you don't know what your PPL file is doing. This will tell you. I use this all the time to